So in 2.3, we're going to talk about the linear functions. These are the things you probably already learned before. So just take a review on that, and things in case you forget something. All right. So a linear function has a form of f(x) equal to mx plus b. M is called the slope and b is called the y-intercept. Okay. So the slope tells how they explain the tilting of the line from the horizontal line. So a big, for example, if you have a large number for the slope m, it means the line it's tilted more. If m is small, then the line is more flattened. And the y-intercept b is the intersection of the line with the y-axis as shown in the graph. You can also find the slope of the line if you are given the line by choosing any 2 points on the line with a coordinates x1, y1, and x2, y2, and use the formula of y2 y1 over y2 minus y1 over x2 minus x1. Rise over run, okay? Or sometimes they are called the difference quotient. Okay, especially a horizontal line has slope 0. Okay, and so vertical line is undefined. Okay, it's right straight, right. So let's do one example of finding slopes. There are 2 points, 2, -4, and -4, 1. We want to find the slope of the line passing these 2 points. So you can call 2 as x1 and the -3 as y1, and -4 as x2 and the 1 as y2, or vice versa. Okay, it really doesn't matter which point you call it 1, which point you call it 2. When you do this, find the slope, you get the same number. Okay, just plug in the formula, you get them y2 minus y1, so that's 1 minus -3 over x2 minus x1, so that'd be -4 minus 2. So on the top it becomes 1 plus 3, the 2 negative signs in here, and then -4 minus 2 is -6. So you got 4 over -6. That can be simplified as -2 or 3 if you cancel 2 on the top and at the bottom. Any questions about the example? Pretty simple, right? Okay, no question. The form we just had in the previous page, fx equal to mx plus b or y equal to mx plus b, is called the slope-intercept form because you can easily read the slope and the y-intercept from the equation itself. Okay, m and b, they are already in the equation. And you can also use the slope-intercept form to draw a line easily. So, for example, if you want to graph the linear equation of fx equal to x minus 1, then obviously the slope is 2 and the y-intercept is -1. So what you can do is you just start from -1 on the y-axis. Excuse me. As the first point, and then you're going to move up 2 units along the y-axis, and then move 1 unit to the right to get another point, right? So that's shown in the graph, and then you just draw the line through those 2 points to get a line. So that's graphing, and you can also have other forms of a linear equation, and in general, it will be written as x plus by equal to c. Okay, that's called the general form of the equation of a line. So let's do some examples of finding the equation of a line. by using the point slope form. So that's another form of equation of a linear function or linear equation. If you are given the slope and the point on the line, then you can use this form to write the equation of the line. For example, if you want to find the equation of the line with slope -3 and pass through -1, 4, there's no A here, I don't know why. It's a typo. So m equal to -3 and x1 equal to -1, y1 equal to 4. Plug into the form, we get a y minus y1, so that's y minus 4 equals -3, which is m times x minus x1, so that's x minus -1. Okay, x, y1 is just the 1 point on the line, right? So on the right side, x minus -1, that's x plus 1. So then you can distribute the -3 on the right to get -3x minus 3. And then on the right, you get y minus 4. So you can add the 4 on both sides to get the -3x plus 1. And combine -3 and 4 on the right. So the equation will find y equal to -3x plus 1. So that's the equation of the line. After simplification, you should always simplify your answer like this, like we're doing here. All right?
Can you stay on this slide, the last
Yeah.
slide?
Yeah. Any questions at this moment? Yeah, just ask me anytime whenever you have a question during the class. Is it good now?
No, not yet.
All right. One thing I forget to tell you is, try to make up the quizzes or tests you missed if you miss anything, and make sure you got the web sign ready before you make up. If you got any questions or anything issues with web sign syncage, call this technical support or contact Mr. Hawks, with his office hours to fix them. Try to make them early. Don't wait out. Just call my cell number when you're ready to make up. Okay. If you missed any test or quiz, but if you already did it, you cannot redo it. If you think there was a problem with the system or software when you took them, just call Syncage technical support and ask them to send me a confirmation email of that.
Okay, I'm good now.
Okay, all right. Some people have not, done any test or quiz. Remember, you already got the Syncage code, so yeah, please use it right away. Okay, the next example. So we're going to talk about real solutions and X-Intercepts theorem. All right. So essentially, these are the same thing. So it says for any function f, the number c is a solution of f(x) equal to 0 if and only if the point c0 is an intercept of the graph y equal to fx. Okay, what does it mean by this? Okay. So it means the x-intercept and the solution for this equation of f equal to 0 is the same. All right. So the theorem essentially tells us how to find the x-intercept. Basically, to find the x-intercept, you just set the function equal to 0 and solve it. Okay, that's the whole thing. about this theorem. So for example, if you want to find the x-intercept of the graph of the function fx equal to negative 2x plus 6, you just set fx equal to 0 and solve for x. And we probably already know that before. Okay, so we got negative 2x plus 6 equal to 0, and then move 6 to the right, you get negative 6. And divide by negative 2 on both sides, so you got x equal to 3. So that's the x-intercept. Or you can put it as 3, 0, if we include both x and the y coordinates of the point. So that's showing the graph, 3 equal to 3, when the line intersects with the x-axis. Can we move to the next page?
Not yet.
All right. I think I received a student asking me about the videos. If you have not been able to find the videos we had, check my email and the announcements in Blackboard. It tells you, one of the emails tells you how and where to find those videos. And the videos are in Blackboard Collaborate. You just go to our class and to collaborate, and then you click on the upper left, and there's a sign of 3 lines or something. You click on it, it shows the you can see the videos. There's a menu popping up. If you click on that, one of those is the videos. Yeah, it's just a icon on the upper left in Collaborate with 3 lines. Click on that, you can see a bunch of things listed, and one of them is the videos recording. It's called recording, and click on that, you can see all the recordings of our classes, previous sessions. Okay, any questions on this example? And also another student asked me about the reading the slides online. Please do not read the slides online and download it. Okay. You just go to the content folder in Blackboard and then download each section of the slide and then read it in your computer. Don't read it online. It doesn't show the whole thing if you read it online in Blackboard. I think it basically is because the compatibility of the PPT PowerPoint with the Blackboard, they're not 100% compatible, I think. All right. Is it good?
Yeah, thank you.
All right. Okay. Okay. So this time we need to find another intersection. That's called the intersections of the 2 functions. So this time it's not, strictly speaking, it's not the x-intercepts. We need to find the intersection of the graphs of 2 lines, y1 equal to 2x minus 1 and y2 equal to negative x plus 11. Okay, but the way to do it is similar. You just set these 2 functions equal. So 2x1 equal to negative x plus 11. So that's where they meet. Okay, and then obviously, just move negative x to the left and it becomes positive, and negative 1 from left to the right, so it also becomes positive. So you got 2x plus x on the left and the 11 plus 1 on the right. And then combine like terms on the left, you get 3x, on the right, you get 12. And then divide by 3 on both sides, you get x equal to 4. So that's the x coordinate of the intersection of the two lines. And then you just plug in 4 for x into any of those equations, y1 or y2. You are going to get the same answer for the y coordinate of the intersection. For example, if you plug in 4 for x in the first equation, 1 equal to 2x minus 1, so then you're going to get 2 times 4 minus 1, which is 8 minus 1, you get 7. So 4, 7. So this is the intersection of the two lines. If you plug in 4 in the second equation, and y2 equals negative x plus 11, you get a negative 4 plus 11 also, y equal to 7, right? So any questions on this?
You're gonna have to grab this type of problem on the quiz.
No. I mean, in the quiz, we have already done some quizzes. You know, they are, the quiz is basically to either multiple choice or you just type in the answer. Nothing need to draw. You know, the drawing, it will be given in the problem if it does, but you will not be asked to draw anything like this in the quiz or test. All right. Any other questions? I just, you know, sometimes it's just I just show this graph so that you can easily view. You know, it makes it a little easy for you. Okay.
The one that you were talking about earlier, where you had to find the x-intercept, we just set that the equation to 0, right? That's what you said.
Yeah,
The
you
previous
said
slide.
you said the fx equal to 0, right?
Okay.
Yeah, or y equal to 0,
Okay.
right? Yeah. So there's a little difference between the intersection of two lines and the x-intercept. That's a good question. Any other questions? Okay, we're gonna move to the next page. All right. So the last thing we're going to talk about is the parallel and the perpendicular lines. When two lines are parallel, then they will have the same slope M1 and M2. Or if you find the slopes of the two lines are the same, then the two lines are parallel. Okay. On the other hand, if the two lines are perpendicular, then the slope of the slopes of the two lines multiply, you get -1. Okay, so 1 minus m2 equal to -1 if they are perpendicular, or they are negative reciprocal to each other. The two slopes are negative reciprocal to each other, so that's the same thing. All right. Or if you find those two slopes have that relation, then the two lines are perpendicular. Okay. So can we move to the next page?
Wait, can you stay on this slide, please?
Yeah. I will put the slides on Blackboard in content.
You can go ahead.
All right. So we have one more section for this. I mean, one more page for this section. Let's just do one example of the parallel and perpendicular lines. So we have two lines, f1 of x equal to 3x plus 1, f of 2x equal to 3x minus 4. Obviously, the slopes of the two lines are the same. They're both 3, right? Remember, the number before x is the slope, and the number afterwards is the y-intercept. So we got the same slope for the two lines, so they're parallel. In part B, we got two G1, F2. I think it should be G2, okay, but it doesn't matter, okay. So we got two other lines, G1 equal to 2x plus 3, the F2 or G2 equals negative half x plus 1. So this time, the slope of the first line is 2, and the slope of the second line is negative 1/2. So they are negative reciprocal to each other, all right? Or if you multiply the two slopes, 2 times negative 1/2 is negative 1. So that means the two lines are perpendicular, okay? Any questions? Yeah, feel free to ask questions if you have any, because
The quiz is gonna be over 2.1 and 2.2, right?
no, the quiz covers everything in this week. So we include them. I don't know when we covered 1.2. I mean 2.1. Oh, if it was covered in this week, then it will include in the quiz. But it will include everything in this week, including today. So 2.3 and maybe even more 2.4 and 2.2 will be included. And I need to double check when we covered 2.1.
All right.
Okay. Any other questions? I think we covered 2.1 in last week, but I need to double check it. Okay. Okay, can we finish this section? Is everybody ready to for the next section?
Yes.
Okay, let me upload the slides of 2.4. So this section is relatively short. Okay, sometimes we make it some short sections, but I already downloaded 2.4 actually. Why did I do it again? I don't know why. Okay, so I'm not going to. So 2.4 is quadratic functions. I think we talked about quadratic functions before. I mean, quadratic equations, right? So, so this is very similar, but we're going to talk about the graphs a little more this time. What is quadratic function? Is fx equal to ax squared plus bx plus c, or a is not 0. Okay. So the quadratic equation we talked about before using different methods, remember, is ax squared plus bx plus c equal to 0. But now we are talking about the function itself in general. Okay, so not exactly the same. And there's some examples of quadratic functions, like fx equal to 2x squared minus 3x plus 1, g of x equal to negative x squared minus 5. H of x equal to x squared plus 5x. So they are all quadratic functions. And if you draw a graph of quadratic functions, you can basically find two categories. One is a parabola opening up, and the other is the parabola opening down. Okay, they're always like one of those. The difference is just that they may have different locations for the vertex and the extent of the opening. Okay, so when the leading coefficient a, the coefficient for the x squared a is positive, then the parabola opens up. When a is negative, the parabola opens down. But all of the curves, quadratic functions, if you draw the graph, they have a symmetry with respect to the vertical line passing through the vertex. Okay, the vertex is either the lowest point when the parabola opens up, or the highest point on the curve when the parabola opens down. And we usually use HK to denote the x and y coordinates of the vertex of the parabola. All right, good. Can we go to the next page? Yes.
Yes.
All right. Okay. So now we're going to talk about the standard form of the quadratic function. It's like when we try to solve quadratic equation by completing square, we also write a function like this: a times x minus h squared plus k. Okay, if you still remember that. And the reason we want to write in this form, by the way, is called the standard form of the quadratic function. It's because we want to find the vertex. Okay, vertex is a very important point on the curve. As you know, it's either the highest or lowest point on the curve. And that's also where the symmetry axis passes through. So that's a critical point. Yeah. But in many cases, when the function is given, it's given in the general form, like in this example, g of x equal to 2x squared minus 12x plus 9. So that's the general form. It's not really in the standard form. So if you are trying to find the vertex of the quadratic function, of the graph of the function, and then you have to rewrite in the standard form from this general form given in the problem. So what you do is the completing square technique, as we learned before. All right. So let's just review how we do this completing square. So the first step is you factor 2 from the first two terms, 2x squared minus 12x. And the reason to do that is make the coefficient of x squared to be 1. Okay, so then you get the x squared minus 6x in this particular problem when you factor out 2 from the first two examples, two terms, and plus 19. All right, and then you complete the square, in the parentheses. Now, if you still remember this technique, this trick in here, you divide the number in the linear term, which is -6, inside parentheses, by 2, and then you square it. This is the number you're going to need to make a perfect square. So you add this number and subtract it at the same time so that you will not change the problem. Okay, so negative 6 over 2 is negative 3, and you square it, you get 9. So you plus 9 and the minus 9. Okay, then you just move out the negative 9 out of the parentheses, but you need to obviously distribute it too, so you get negative 18. But you keep the other thing inside the parentheses. And that product will give you a perfect square of x minus 3 squared. All right? Or x minus 3. If you factor that, x squared minus 6x plus 9, you're going to get x minus 3 squared. So the problem just becomes 2 times x minus 3 squared, and then negative 18 and positive 19 combined to give 1. So in that way, we can rewrite the quadratic function in the standard form, and we can easily read the vertex from this standard form. Remember, the standard form is fx equal to a times x minus h squared plus k, okay? So be careful about the sign here. So if we compare the standard form of the quadratic function with the example we have in here, then you'll find h equals 3 and the k equal to 1, isn't it? So the vertex of this parabola is actually at 3, 1, as shown in the graph. Any questions? Does not make any sense?
Why did you multiply it by the negative 9 and not the positive, like both of the 9s?
Because we need x squared minus 6x plus 9 to factor out. We don't need the negative 9 in here. The product x squared minus 6x plus 9 will be factored to x minus 3 squared. And we don't need anything else. That's why you add the 9 and subtract 9. That's the reason why we add the 9 and subtract 9, because it is needed to make a perfect square of x minus 3. And that's the whole point of completing the square. Any other questions?
Oh, why you square that negative 6 over 2?
That's the way to make a perfect square. It turns out this is the number you need when you try to form a perfect square. You need to add the number, to x squared minus 6x to make it to x minus 3 squared, and the number turns out to be 9, or negative 6 over 2 squared. That will end up with the number you need to make a perfect square.
Right.
Yeah. So this is the rule that people summed up and summarized. Any other questions? You just if you're not quite sure, that can be easily proved, but if you're not sure why, just follow the steps. That's the way it is. Okay, it can be easily proved. Any other questions? Can we go to the next page? Yes.
Yeah.
All right. Okay. Okay. Now let's talk about the vertex of a parabola in general and how we, make the perfect square. Okay. So this time we're going to deal with the more of those symbols instead of numbers, but the way to do is always the same. So we are given a quadratic function in the general form of x squared plus bx plus c, and we are trying to rewrite this function in the standard form like we did in the example in the previous page, but we're talking about the more general case. So, so the first thing is to rewrite bx as a times b over ax. Okay, and the reason for that is we want to factor a from those first two terms. If you remember, we factor the number in the leading term. So that's why we rewrite in that way. Okay, so then if you factor a from the first two terms, you're going to get x squared plus b over ax, and you just leave c as it is. And then the next step is to divide the number in the linear term by 2 and squared, right? As we did in the previous example. So in here, the coefficient of the term is b over a. So we divide b over a over 2. So you get b over 2a. And you square it. And that's the number you add. And then you just need to subtract the same number in order not change the problem. Okay? Not change the function itself. So you add b over 2a squared and minus b over a squared. Okay, so this is the same procedure we just did in the previous example, but we are talking about a more general case. And then again, you're going to move the negative number in negative b over 2a squared outside and leave the other three terms in the parentheses. So we got a times x squared plus b over ax plus b over 2a squared minus a times b over 2a squared. Okay, you have multiply, a when you move out, plus c. And then just like before, for any problem, the first part, x squared plus b over ax plus b over 2a squared, turns out to be the x plus b over 2a squared. Okay. So you can factor, that part into a perfect square, like this. And then the second part will be negative a times b over 4a squared. If you square b over 2a, you're going to be square over 4a squared. And then, you can cancel 1a from denominator to get the negative b squared over 4a. So that's just the a times x plus b over 2a squared plus c minus b squared over 4a. If you switch c and negative b squared over 4a. All right, and then you can try to combine the two terms, c and negative b squared over 4a by using the common denominator for a. So you can rewrite c as 4ac over 4a, and then combine those two terms. You get 4ac minus b squared over 4a. They have the same denominator. So so we got a times x plus b over 2a plus 4ac minus b squared over 4a. And we just go one more step, rewriting x plus b over 2a as x minus negative b over 2a to match the standard form, which is a times x minus h squared plus k. If you remember, the standard form of the quadratic function is a times x minus h squared plus k. If you look at the previous page, the standard form of the quadratic function is f of x equal to a times x minus h squared plus k. Okay. So that's why we need to, put the minus in here. So then you can read the h and the k from the function. Okay. So the whole thing we have done so far is just to rewrite the function from the general form of ax squared plus bx plus c into the standard form, into the step. Yeah. You need to manipulate those symbols a little bit, but at the end, that's what we get. So if you compare with the standard form of the quadratic function, f equal to a times x minus h squared plus k, then we have h equals negative b over 2a, right? X minus negative b over 2a. So h is just negative b over 2a, and k is just 4ac minus b squared over 4a. Okay, so what's the point? The point is, given in the quadratic function in general form, ax squared plus bx plus c, how do you find the vertex h and k? So this is the formula to find the vertex from the general form of a quadratic equation or function. But you don't have to memorize all the formulas. What you need is just the remember h equals a negative b over 2a, and you can actually find a by plugging h into the function itself. Okay, so if you do that, f of h, okay, so h equals negative b over 2a. If you plug in that h for x into the quadratic function, so you're going to get f of h equals a times h minus negative b over 2a squared plus 4ac minus b squared over 4a. So that's what we got in the last step and in the first part. So that's equal to a times negative b over 2a minus negative b over 2a, and that's h. Remember, replace h by negative b over 2a, and then plus 4ac minus b squared over 4a. But then you got a 0 in the first part. Negative b over 2a minus negative b over 2a is 0. So you get a times 0 squared plus 4ac minus b squared over 4a. And then the first term is just 0. So you're just left with 4ac minus b squared over 4a, which is k. Okay. As you read from this standard form. So the point is, you can find the vertex of the parabola as negative b over 2a and f negative b over 2a. Okay. Or f of h. So this formula gives us the way to find the vertex of the parabola from the general form ax squared plus bx plus c. Fx equal to ax squared plus bx plus c. The vertex will be at negative b over 2a and f of negative b over 2a. Okay, so you don't have to go through all the steps again, completing square. This is summarized the